Peekaboo, here I am. Okay, hope you like that. You were like, what? It's the start of the video, but he's not here. What is up with that? I am here, tricked you. In this video, we're going to be going over casework and probability. It can get very tedious and annoying, but you need to know how to do it, and you need to know how to do it well. Josh rolls a standard die 3 times. What is the probability that the third roll is greater than the sum of the first 2 rolls? So if this will be the first roll, and this will be the second roll, B will be the second roll, then the third roll has to be greater. So we can do casework for this problem, as you might think. We can do it for when the third roll is a 6, because when we have a 6, you could have cases where A plus B is less than 6. Also 5 and 4 and 3, you can't go up to 2. So we have these 4 cases that we need to consider, and inside each of these we're going to have a bunch of different more cases. So let's start with 6. So now I need 2 numbers whose sum is less than 6. So of course we could say 1, 1. We could say 1, 2. We could say 1, 3. We could say 1, 4. But we cannot say 1, 5, because 1, 5, the sum is 6, which is equal to 6, and we need it to stay less than 6. So now we're going to move on for the first die roll being a 2. So we could have 2, 1. 2, 2, and 2, 3. Notice we can't have 2, 4 because that would sum to 6. And now we could also have the first roll being a 1, being a 3. And then we could have 3, 2. We can't have 3, 3 because that would sum to 6. And then we could have 4, 1, and that's it. And there are no 5 cases. And so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to put a 10 right up here. And now let's move on to 5. So now the sum of 2 numbers has to be less than 5. So we could have 1, 1, 1, 2, 1, 3, and we can't do 1, 4. Then we could have 2, 1, and 2, 2. And then we could also have 3, 1. That's 1, 2, 3, 4, 5, 6 cases. And now we still need to check 4 and 3. So for 4, we could have 1, 1. We could have 1, 2. We can't have 1, 3. And we could have 2, 1. That gives us a total of 3. And now for 3, we only have 1 case for a total of 1. And so now the sum of all the numbers would be 10 plus 6 plus 3 plus 1, which equals, that's 4, that's 10, that's 20. So our numerator is going to be 20. Now we just need to figure out what the denominator is going to be. So again, just like we've been doing for all of probability, probability is written as the good outcomes over the total amount of outcomes. So this 20 over here represents the good outcomes. Those are the number of ways that the third roll is greater than the sum of the first 2 rolls. And so now in the denominator, the total number of ways that we can roll 3 die. So for the first die, we have 6 different options. In fact, I'll even just draw a die so that we're clear. You can have a 1, a 2 here, a 3 there, and then it goes around. So on this die, there are 6 different options that it could be, and there are 3 of them. So you have 6 options 3 times. And those are the total different ways that you could roll any die. So you could even do a tree graph out of this to prove it even more creatively. So on the first side, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. And then each one of these, 1, 2, 3, 4, 5, 6. So this says you could roll a 1 and then a 3, a 1, a 1, a 1, a 6. Or you could roll a 2 into 1, a 2 into 2, a 2 into 3, a 2 into 4, a 2 into 5, a 2 into 6. And you do it for all of these. And then I'll just show for the fourth. You'd have a 1, a 2, a 3, a 4, a 5, and a 6. So you can see that you're going to have 6 over here, and then each individual one is going to have 6 more, and then each of those individual ones are going to have 6 more. So it's going to be 6 cubed. So the answer is going to be 20 over 6 cubed. Now moving on to the second problem. Three of the vertices of a regular heptagon has 7 sides, I believe, are connected to form a triangle. What is the probability that the triangle formed is isosceles? Okay, so to draw a shape like that, I'm just going to draw a circle, and then I need to put 7 equally spaced dots on here. Ugh, that's not good. Here, maybe I was right in the beginning. Okay, that's okay. And then you could also just take away this, and you're left with a gorgeous heptagon that you could have never drawn otherwise. That's the power of the circle. Okay, so what is the probability that the triangle formed as isosceles? So in the denominator, we're going to have just choosing 3 random spots. How many different ways can you do that? Well, that would be we have 7 points and we're choosing 3. So the denominator would be 7 choose 3. And now if you want to evaluate that, you would say that's equal to 7 times 6 times 5 over 3 times 2 times 1. The 6 cancels out with both of those, and so you get 35. So I'll even just write 35 in the denominator instead. And now for the numerator, we're going to find out how many cases can the triangle form to be isosceles. Again, an isosceles triangle, that's when 2 of the sides of the triangle have equal length. So we could have, I'll get a different color for this. We could have an isosceles triangle right over here. Another type over here. In fact, this is an equilateral triangle, a type of isosceles triangle. And then you could have another one over here. And for each of these 3 different cases, you can rotate it so that it's centered around each of these 7 dots. So that would be 3 times 7, which equals 21 cases. So our answer is going to be 21 over 35. You can factor out a 7. That's 7 times 3 over 7 times 5. So our final answer is 3/5 of the time, which is the majority. Thank you very much for watching, and goodbye.